Semiconductor technology is on the brink of a revolution, thanks to a groundbreaking Japanese innovation in chip manufacturing. How will this seismic shift impact the global tech landscape and challenge the existing hierarchy? In today's video, we will delve into the impressive advancements in semiconductor technology and the groundbreaking lithography equipment created by a Japanese company. This equipment is causing a significant transformation in the industry. Lithography, a critical component of the semiconductor field, has always held a high reputation. Experts in the global tech industry have continuously strived to push the boundaries of lithography technology. ASML, a prominent player in this field, once confidently stated that even if they provided the blueprints for their lithography machines, no one could successfully replicate their technology. This underscores the intricate and highly integrated nature of the manufacturing process for lithography machines, which is part of a complex supply chain. This complexity has deterred many from entering the industry, making lithography machines an indispensable component in the world of semiconductors for a long time. However, an unforeseen twist of events occurred with the debut of Huawei's M60 series. To the surprise of many, China managed to create highly precise chips like the Canon 9000 without relying on ASML's EUV lithography machines. This accomplishment served as a resounding answer to those who had underestimated China's technological prowess. Despite relentless efforts by the United States to uncover the secrets behind the Canon 9000 chip, its technical details remain elusive. Now, an even more significant revelation has sent shockwaves throughout the industry, reigniting curiosity and excitement. Canon, a Japanese firm, has announced the sale of chip production equipment capable of crafting 5-nanometer chips. What's truly astonishing about this technology is that it sidesteps the conventional and intricate lithography methods and instead employs nano-imprint lithography. Nano-imprint lithography might be unfamiliar to many, but it operates in a manner akin to an ordinary printer. It directly imprints the chip structure onto a silicon wafer, seamlessly integrating into the chip manufacturing process. Despite its apparent simplicity, this innovative technology has the potential to substantially reduce manufacturing costs, marking a genuine technological revolution. ASML has held a dominant position in the lithography field for the past 2 decades. However, Canon's new technology seems poised to disrupt this dominance. For ASML, its market share and global leadership in the semiconductor industry now face a significant threat. On the other hand, for other companies, this presents a remarkable opportunity, as replicating nano-imprint lithography technology appears to be less challenging than reproducing lithography machines. ASML once displayed overconfidence by claiming that even if they provided the design blueprints for their lithography machines, others couldn't replicate them. The complexity of lithography machine manufacturing and the intricate supply chain have discouraged potential entrants. Nevertheless, the landscape has shifted dramatically with the release of Huawei's Mate 60 series. China's ability to produce highly precise chips like the Canon 9000, even without ASML's EUV lithography machines, served as a powerful demonstration of their proficiency in nano-imprint lithography. The tech industry continues to buzz with significant developments. This time, Canon, a Japanese company, has ignited a new wave of technological enthusiasm. Canon's chip production equipment is capable of creating 5-nanometer chips, departing from traditional intricate lithography methods by utilizing nano-imprint lithography. In the realm of semiconductor manufacturing, lithography machines have long been seen as costly yet indispensable equipment. Nano-imprint devices are seen as the next-generation alternative by several Japanese semiconductor equipment manufacturers, promising cost-effective mass production of chips compared to traditional complex optical lithography methods. Nano-imprint lithography is a micron nanoprocessing technology based on the principles of miniaturizing traditional mechanical molds. Let's take a pause and ponder this. How will nano-imprint technology reshape the future of semiconductor manufacturing? Is it the dawn of a more efficient and cost-effective era in chip production? Share your views in the comments below. And don't forget to subscribe to Revel Technology on YouTube for more insights into the latest tech trends and breakthroughs. Conventional lithography machines project circuit patterns onto a silicon wafer covered with a special coating, sort of like shining a picture onto a canvas before painting. Nano-imprint lithography, on the other hand, directly stamps the circuit pattern onto the wafer's coating, similar to pressing a stamp into ink and then onto paper to create an image. This technology was kept secret by Canon, who began working on it in 2004. It only became known publicly in 2014 when Molecular Imprints, a U.S. company now part of Canon nanotechnology, joined the effort. In the spring of 2021, simulations by Nippon Printing suggested that nano-imprint lithography could significantly reduce energy consumption during chip manufacturing, making it much more efficient than the conventional EUV exposure method. They believe that nano-imprint lithography, or NIL, can be used to create chips at the incredibly small 5 nanometer size. Companies like Keixia, Canon, and Nippon Printing are actively researching this technology and hope to make it available commercially around 2025. According to Nick Asia, nano-imprint lithography has the potential to cut chip manufacturing costs by about 40% and reduce energy consumption by approximately 90% compared to EUV lithography. It has a wide range of potential applications, including integrated circuits, memory storage, optics, life sciences, energy, environmental protection, and defense. Nano-imprint lithography is particularly good at making different types of integrated circuits and excels in producing storage chips, like 3D NAND and DRAM. Unlike logic circuits and microprocessors, making storage chips requires strict cost control and allows for more tolerance for defects, making nano-imprint lithography a great fit for storage device manufacturers. These manufacturers were among the first to adopt and promote nano-imprint equipment. Reports suggest that Canon delivered its nano-imprint semiconductor manufacturing equipment, the FPA-1200NZ2C, to Toshiba Memory's Geki plant in July 2017. Additionally, it's rumored that SK hynix plans to use Canon's nano-imprint equipment by 2023 for mass-producing 3D NAND chips around 2025. Canon historically lagged behind ASML in the semiconductor equipment sector, so nano-imprint lithography gives Canon a chance to catch up. In a statement, Canon admitted that, like their competitor Nikon, they have fallen behind ASML in the race to develop EUV lithography technology. Canon's nano-imprint lithography approach holds the potential to narrow the gap with ASML in the semiconductor equipment sector and create new opportunities in the market. Currently, the reliable production of 5 nanometer and smaller chips relies on EUV machines, which can be subject to import restrictions in some countries. However, Japanese companies' nano-imprint technology sidesteps the need for traditional lithography by directly imprinting circuit patterns onto silicon wafers, reducing the likelihood of being affected by existing trade restrictions. Canon has not provided information on whether the new equipment is subject to Japanese export restrictions. In summary, ASML, a Dutch company, has long been a prominent player in the European tech industry. Based in the Netherlands, ASML has enjoyed consecutive quarters of revenue growth and a surge in orders, solidifying its position as the preferred supplier of EUV equipment to leading chip manufacturers worldwide. Canon stock has also experienced significant growth, with an expected 30% increase in net sales for the current year. This growth is driven in part by the overall rise in the Japanese stock market and increased demand for chip manufacturing equipment, especially in artificial intelligence applications. While Canon has primarily focused on producing less advanced chips, they are in the process of constructing a new lithography equipment factory in northern Tokyo, set to begin operations around 2025. As we delve into the groundbreaking advancements in semiconductor technology, what are your thoughts on the potential impacts of this innovation on the global tech industry? Engage with us by leaving a comment, subscribing to our channel, and clicking the notification bell for regular updates. Keep watching, stay inspired, and get ready for more exciting discoveries. See you in our next episode.